Thank you for being here. You know, it's late in the day. We've had a number of wonderful talks, and I want to add to that collection of tools you can take to your classroom by talking to you today about how to teach your students to formulate questions. So what I want to do in this talk is first do a little mathematics, because I love math, and we should do some math. And that will give us a basis for me to illustrate that skill to you, okay? So we're going to do a little bit of math, then a little bit of pedagogy, and then we'll see where we are from there. So I'm going to show you what I have often done day one in my abstract algebra course. And that means even though it's an example from abstract algebra, it's from day one. So you don't need to know any abstract algebra. So I thought that'd be a great choice. So we're going to do a think, pair, compare, which is a variant of think, pair, share. And the think part, for those not familiar with this, means I'm going to put a prompt up here and ask you to be quiet. Whether or not you think is up to you, but be quiet so other people can, okay? So that's the hard part. So I'm going to put a question up here, and it's going to be even harder because it's vague and incomplete, and you're all mathematicians, so that's going to drive you crazy. So just breathe and work with it, and we'll be okay. So you get the rules. We're going to think for a minute. I'll let you know when it's time to talk with other people. Okay, here's the question. How many solutions does x squared plus 1 equals 0 have? So let's think. You're welcome to write. Put your hand down. Thank you. So you're welcome to write and think. How many solutions, if you had to answer this, how many solutions does x squared plus 1 equals 0 have? I'm going to guess that you probably all have an answer. So let's shift to the next stage, which is, would you please introduce yourself to the person next to you? And will you share the answer you had with your neighbor? So I'm going to do something so that we can have a sense of closure with what we just did. But rather than call on you to tell me your answers and your explanations and all that, and I assume you can, I'm going to share what has been sort of the most popular answers to this question among my students. And you can compare what you said to which were popular among my students. So let me tell you what the survey says. This is over many years. And this is like Family Feud style, so when I pop up the answer, would you all say it out loud just for kicks? Okay, so you've seen that show? So number one answer, 0. Thank you. I know, there's some complex analysts in the crowd. Number 2 answer, 1. Consistently for 10 years running. Okay, number 3 answer was 2, and the last answer was probably what most of you thought but didn't think was acceptable to say, and that's it depends. So you haven't told me what field we're over, or if it's real, if I'm allowed to use complex numbers, etc. Okay. So I introduced this question on day one of abstract algebra because abstract algebra actually, one of its historical roots is solving equations. And so it's actually relevant to the content of the course to talk about what are we allowed to use when we solve equations, which number systems might be acceptable, et cetera. So this is really on point to what we're going to be talking about during the semester. And so before I start talking about the teaching part of this, let's look at answer number 2. Consistently, the second most popular answer is 1. Which one solution is it they're thinking of? Do you know? It's the square root of minus 1. Right? It's the square root of minus 1. Obviously, it's unique. Okay, so one solution, I didn't expect this the first time I taught it. I love wrong answers. Wrong answers are the best, right? The best. 0, 2, boring. 1, fabulous. Why? Well, because it leads to a really good question, which is, could there be one solution? And pretty quickly, my students will say, well, it can't just be I, because minus I would work. And you know, that's always going to work. If you put a positive n squared or a negative n squared, you get the same thing. So anytime, they might not say it this formally, day one, but anytime alpha is a solution or a root, so is negative alpha. And so immediately they go, aha, there's always an even number of solutions. given that they have example of 0 or 2, I guess that's okay, but that's a pretty big leap. But of course, that's very reasonable. You always have alpha and minus alpha. They're in pairs. There's always an even number. Okay. At this point, you need to know that my students would have seen modular arithmetic and discrete math that comes before this. And so when I ask them, well, are there places besides R and C where this equation makes sense, they can see that in the integers mod 2, so just 0 and 1 with addition mod 2, there's only one solution. 0 works and 1 doesn't. And you can see what went wrong there. In the original argument, alpha and minus alpha aren't necessarily distinct. Okay, so the people who said 1 were right. They were just in the wrong field. So, and we will come back to this math in a minute, okay? Okay, we'll be back to the math in a minute. I needed to give you a context, though, for us to work on a particular teaching skill, and that is teaching students to ask questions. And I use this quote in the abstract, and I will read it here. It's a touchstone for me. The test of a good teacher is not how many questions the teacher can ask that the pupil will answer readily, but how many questions the teacher inspires her pupils to ask that she finds hard to answer. And this has been a touchstone for me. I use questions as a basis for everything that I do, and part of it is helping students to pose and formulate questions. In case you need more motivation for why, I'll give you 3 different reasons. Pick whatever you like. 1 is usually good enough. Questions seem to foster student curiosity, so if you're teaching an IBL course and you're creating problems to use, questions might be a good type of problem to incorporate rather than just prove this, prove this. Posing questions helps students learn. I'm sure you've said to students, well, figure out how to ask me a question. And as they do that, they figure out what they don't know, and they don't need to ask you a question anymore because the question posing process helps them learn. And of course, I would argue, even if neither of those is important to you, questions are the heart of what mathematics is. It's what research is in mathematics. Mathematics, if you want to tell anybody, what do? We pose good questions, among other things. So it's just part of the content we should be teaching, in my opinion. All right, so we're going to practice some question posing activities that I do with my students, and I'm mindful of the fact that you're really good at posing questions, so we're going to let you fly without a net for a minute first, which I would not do with my students. So we're going to pair up with the same person you introduced yourself to, and I would like you to write 3, 4, 5 questions about solving this equation other than the one I used, which was how many solutions are there. So any questions you want other than the one I used. You can write them, speak them, whatever works for you. I'd probably write them down. Okay. Now, I will tell you that I can't eavesdrop very well from up here, which is a critical element of my teaching, eavesdropping on my students to know when we're ready to move. I am hearing little bits of people answering questions, but mainly people posing questions. So that was good to stay on task there. That was good. Posing questions is something that you're probably a lot better at than your students, but they didn't start out life that way. They started out life being really good at posing questions. If you've ever spent time with a 3-year-old, you know what I mean. Mommy, why is the sky blue? Is the sky blue at night? Does the blue go away? Where does it go? Is it white? Is it hidden behind the clouds? Why isn't it green? Okay. And at some point, someone turned to them and said, please stop asking me questions. And unfortunately, over the course of their education, they may have taken that a little too literally, and now they're not as experienced or as curious as they once were. And so part of the reason for teaching them to pose questions is to reinvigorate that curiosity. And it is something they can do. But even you, who are really good at posing questions, just flying here without a net is kind of awkward, wouldn't you say? I mean, some of you maybe were good at it. Some of you I could see were like, how many solutions does it have in Z3? Yeah, that was a good question. It is, it's a good question. And I don't know anymore. Oh, I could do Z4, you know. And so it's hard. I mean, even for experts, and we're experts in asking questions. So if you got a whole bunch of really different ones, kudos. So let me show you a technique for students who are even more hesitant perhaps than you to write questions that can be used to generate a broader range of questions as well as getting over that awkward silence of like what should my first question be? And what there are, and they're not, I did not invent this concept nor this name for it, is question stems. And so I'm going to show you some question stems and ask you to use those to write more questions. So you're probably like, well, what's a question stem if you've never heard of these? They're also known as question starters, probably a better name. In other words, they're the first half of the question. All they're missing is all the content. Okay? It's the form, but not the content. So there's many of these. I have a reference I'll give you later that has many more of these. They can be organized by Bloom's taxonomy. They can be organized in all sorts of different ways. But let me just give you a few I like. So here's a few question starters. And now I'd like you to go back to your pairs. And can you read what's up? Do I have to read it out loud? You can see it, right? Okay. And I'd like you to go back to your pairs and come up with at least one question, again, about solving x squared plus 1 equals 0. But with this as the beginning of your sentence. Do you see what the instructions are? Okay. All right. Elana, see? Your turn and talk to somebody else. I call you. Can you, did someone, one of you come up with give me an example of one of these? Let's make sure we're on the same page. Can you do it?
Can I do the answer?
Oh, I was calling her. Thank you, Susan. Do you know what we're doing? Do you have one of these? Yes, to continue it. So could you give me an example just to make sure everyone knows what we're talking about here?
Hi, everybody. I'm Elona, and that's the only name she knows, I think.
No!
No, it's okay. Thank you so much. In our group, we have like different discussions, but we were working with regenerating more questions first. Mm-hmm. And we were discussing that in case of having the x squared plus 1, we can have any different natural number there. Will it change how many solutions will come there to regenerate more questions from the students? But then when it comes to the questions that you wrote down and we need to finish them, I was going to say, why is it true that in this case we have 2 solutions, for example?
Sure.
And that will regenerate a lot of pool of questions where the students will go crazy saying, well, no, it's not true or something, and how did you come with that? So that will be one example.
Thank you. Do you hear the question? So using why is it true that there are only 2 solutions, say, in the complex numbers? Sure. Okay, so do you get the idea of these? So students who sometimes are hesitant to ask questions, my experience has been, are happy to have things like this to try. And at first they may ask extremely dull questions because they're just trying to finish the sentence. What's an example of a solution? How do I find a solution, et cetera? But then they start getting deeper. What's an example of a ring where there would be however many solutions? I mean, you can start to get to very deep and very interesting questions from just really, very simple question starters. Okay, another technique that is very effective, and I think you were already starting this, so as I would expect, is to create new questions using the strategy what if not. And you may have heard of this before. So what if not, and I will do one of them for you to help it in case you haven't seen this. To ask, for example, what if not 0? And actually, Eliana, I think this is the one that you used, right? So what if it weren't 0? It was some other natural number, some other whatever kind of number. And you might ask, how many solutions does x squared plus 1 equals c have? So the thing that I said, finish the what if not with was 0. There are many other things in that equation I could have changed. So will you now add to your list of questions by changing each, or as many as you like, of the other things in there? So have you had a chance to do this? Have you had a chance? You have a chance to do so. All right, again, I can't eavesdrop very well, so I'm gonna guess that you've had a chance to at least start this process, okay? So ideally you have, either in writing or in your head, a whole bunch of questions. Ones you just came up with on your own, ones that maybe were inspired by question starters, ones that were maybe inspired by what is not. I would like you to look at what you have because I'm going to go through each of the tables and ask one person at each table to give me a favorite question. But all I ask is that you not repeat a question someone else has said. So when you say a question, thereafter, you are responsible for making sure nobody asks your question. And before you get called on, you're responsible for making sure you listen carefully so you don't ask the same question. You understand? So this is sometimes, we did those two things. It's sometimes called no repeats. So it's a reporting out mechanism. And I'd like you to hear some of the questions. There's certainly some interesting ones there. So we're going to start this. So TJ, will you be our first? Will you tell us one question that you really liked? Can that work?
I'm here. Okay, hi, I'm TJ Hitchram from the University of Northern Iowa. So my favorite question actually is, what if X was a function?
Okay. And the second table, will you step to, someone quick, step to the mic who hasn't spoken before? Oh, TJ's not going to, yeah,
Great.
sure.
Okay, so one of our questions was, what if it's not squared, but another natural numbers, but we were saying in F2?
Okay, okay. You're still obviously too. Okay. Thank you. Good. Tell us the question.
I'm Ryan Dunning from St. Mary's in San Antonio. We didn't phrase this as a what if, but we've got the question. For which values of C does the problem become fundamentally different versus other values of C?
Okay. Yeah, Mary, make some, there you go, thank you.
One question I had on my sheet is, is there an example of another equation with exactly the same solutions?
Great question. All of these are great questions. Very high level question. Just tell me one. Please don't repeat.
I'm Kirsten from University of Oklahoma, and our question was, what happens if you change it to x squared minus 1?
And up here, be ready. We're coming to you.
Victor Piercy, Ferris State University, and you said a number of the ones that we really like, but here's one. Can you give an example of, I don't know, space, ring, field, whatever, it's not really a field, but a space where there are exactly 6 solutions to this equation?
Okay, and we'll take 2 more. So I'm sorry, that's not every table, but 2 more.
Miloš Savić, University of Oklahoma. What if the coefficient of x squared were different?
Okay. So what if it was not the one you can't see? I love that one. Go ahead.
Okay, Danielle Champney from Cal Poly in SLO. A good one might be give a situation in which an answer of 2 solutions is correct and an example of a situation in which 2 solutions is incorrect. So contrasting.
Sure. No, wonderful. And part of the reason that I had my students in abstract algebra actually generating questions is because this was the beginning of their research project for this semester. And so having a whole bunch of questions, some of which are easy to answer, some of which are not so easy to answer, some of which are so broad they would make many semesters of research, is a great place to start. They always like, I don't know where to start, what my questions are. So we did this, and I want to stop here and let you ask me, depending on how much time Judith says I have. Can we do questions? Okay. So I'd like to, first of all, thank you for participating in this. Hopefully you took away a few ideas about teaching your students to pose questions. So thank you. And then we'll go to questions. How's that? And then we'll go to questions. So some of you have heard me speak, know a device I often use at talks, which is I write down some questions that I want to answer, but you're welcome to ask me things that aren't on this list as well. So what would you like to know more about? Yes?
I had 2 questions about questions. One is, how do you treat sort of the aesthetics of questions? So you were talking about some questions are dull or some questions are good. So how do you have those conversations with your students? And then the other question about questions is, which of these questions do you choose to pursue, like to answer?
Sure. So about the aesthetics of questions, usually if my goal is to generate a list of questions, we're not evaluating them at all. We're trying to get a list down there, just have a place to start. And their homework assignment might be to all answer a question or 2 that I want them to work on for a warm-up, or it might be to pick a question and explore it or things like that. So students have a variety, so the logistics of the research project, students may There may be some questions, there are some questions that I ask them to walk through as we go through the course, and then they'll come back to their question list to do a more open-ended piece at the end. So some of the questions they may have picked, we may decide to all do. I usually have them work, for example, through the integers mod n in general, which is non-trivial, actually it's very interesting, or through a matrix ring or something like that. And then a student may explore functions, and a different student may explore things leading to the quaternions or other things like that. So they may go different directions with that. So usually a combination of scaffolded required and open-ended choose. That answers. Yes?
Number 4.
Number 4. Yes. The answer is yes. No. And I debated doing with you what I actually do in a Math for Liberal Arts or a pre-calc class or other classes, and that is to have you pose questions about an everyday object instead of a mathematical object. So I was tempted to bring a Ziploc bag, which is one of my favorites. So you might use slightly different question starters, but you'd be amazed how many questions you could ask, for example, about a Ziploc bag. I used to use neckties, but nobody knows what those are anymore. So, and so I've had students warm up on something that's not mathematical, although there are a lot of mathematical questions about a Ziploc bag. Do you know what I mean? A plastic, you know what I mean? Okay, a little plastic bag. So I've used it in other courses, and sometimes one of their assignments might be to actually pose questions. So for example, my several quantitative reasoning courses I teach, the first project is to create a project. So to pose the questions and get the data and things like that. So I do use that often, yeah.
So my question is, what if you wanted to know how often you do these kinds of activities and how do you distribute them through the semester?
Sure, so I might do the question posing once or twice during the semester formally. Once you get them going, it's hard to make them stop. So because we're doing a lot of inquiry things, they're asking questions all the time. So I might do one or two times formally to generate questions. Once at the beginning and once when we're kind of hitting a dull point, need to get some new questions out there.
Hello. So this is just a comment that there are also question stems or starters for when students are in the audience and they've just reviewed a presentation by another student, things like how did you know to,
right,
and so on. And so that's related to all the things that you're doing, that you could also drop that into the same framework.
That's fabulous,
I'm talking
yeah,
to all of us and use that as a way to generate more questions during student presentations.
Yes, and I grabbed like 5 starters I like. These are probably not the best class starters. There's things, how do you know, and other ones that are probably better for that. But I'll add that to my list for, yes.
Yeah, and just sort of building on what Stan was saying too, there's also ways to build this into assessment and to sort of elicit different sorts of things from students. So the difference on exams between asking which is the right answer versus this one is incorrect, why, you know, versus sort of framing those all in different contexts. There's a lot of good research about how the quality of the answers you get is very different. And so that's another sort of adaptation of the question stems that I think we could all take something away from and maybe change up our assessments a little bit to evaluate students differently.
I appreciate, thank you for that comment. So as you go through the day and tomorrow, I invite you to think about the integers mod n. There's some interesting things there that I won't tell you. But let me put up, why should I tell you? That takes all the fun out of it. I will tell you where the answers are. There's a rather old article of mine in Primus that has some of the answers there. It also does not have an answer to whether there's ever 6. Thank you for asking that one. I don't actually know the answer to that. I should. And then there's a variety of resources here about active learning, about teaching questions, what if nots, question starters. None of that is original to me. I have found this very effective, and I hope you will give it a try to teach your students actually how to formulate questions. So thank you again.